Alright, welcome back. Grade 11 trigonometry, the basics, just those simple things for someone who may be struggling. This one you definitely can get it right without any problems. So in this particular section, let's quickly go through reduction formulas and core functions. Reduction formulas and core functions. How do reduction formulas work? Just a quick reminder, like we discussed in the previous video that we once did, and in the lesson that we also had, we discussed the Castor rule. I need to study this diagram and you know it very well. That when we are measuring angles, we start on the positive side of the x-axis with 0 degrees to 90 degrees, which means in between here, I've got angles that are from 0 up to 90 degrees. Then from 90, when I'm here, I've completed a straight line which is 108 degrees. So in between here, I've got angles from 90 up to 180. Then in between here, I have angles between 180 to 270. And then here, I have angles from 270 up to 360 degrees. These are the angles that are in each particular quadrant. Then written in terms of variables, in quadrant 1, the angle is theta. In quadrant 2, the angle is 108 degrees minus theta. Then in the third quadrant, the angle is 108 degrees plus theta. And in the fourth quadrant, the angle is 360 degrees minus theta. These are the measurements of the angles. Then we need to know which trigonometric expression is positive in which quadrant. In quadrant 1, all of them are positive. In quadrant 2, sine is positive. In quadrant 3, tan is positive. And in quadrant 4, cos is positive. So generally, I need to know this off in my mind. I must study it so well that I know this in my mind. Then these come together with the core functions. So core functions, we also showed you how to prove them. We also showed you where they come from. So generally, 90 degrees plus or minus theta means core functions. So if I have got the sine of 90 plus or minus theta, this is equivalent to the cosine of theta. Then the cos of 90 degrees plus or minus theta, this will equal to negative minus or plus the sine of theta. These are my core functions. Now in this particular section, this is just to remind you what we did. In this particular section, I want to quickly go through the reduction formulas and the core functions and see how these are applicable in solving problems. So let's look at this question. The instruction is simplify the following expression. Tan 108 degrees minus x divided by the sine of 90 minus x multiplied by the sine of 180 plus x. So first of all, if an angle is added or subtracted from 180, the 180 falls away. This is reduction formulas. So if I see this 180 and that 180, both of them, they definitely are telling me that I must do reductions. If you see 90 degrees, one item, this is going to need core functions. So reductions and core functions. Now I simplify my expression. The 180 falls away. There is no any reasoning required around that one. And the answer is going to become tan x. What is important now is the resulting number is going to be positive or negative according to the quadrant in which the angle is. So the tan of 180 minus x is in the second quadrant. In the second quadrant, tan is negative. Therefore, this must be negative tan x. Without that negative sign, the answer is definitely wrong. So I need to be sure about this. Then at the bottom part, the sine of 90, when you are doing a core function, the sine falls away and this one changes to cos. So that is going to be cos x multiplied by, I come here and do the same thing. This is the reduction formula, sine 180 plus x is equal to sine x, and it's a negative one because sine is 180 plus x is in the third quadrant where sine is negative. So in general, this is not like a policy, but in general, I expect the examiner to credit me for those three that I have changed, the reductions for those two and the co-functions for that one. Then to simplify further, normally after applying the co-functions and the reduction formulas, you will notice that the next part may need you to apply identities. And in grade 11, we have done two identities only. Sine squared theta plus cos squared theta is equal to 1. And sine over cos is equal to tan. So in this expression, I'm going to change tan. It's going to be sine x divided by cos x. And it's a negative 1. Now, if you are working with an expression where there is a fraction on top of another fraction, I advise, it's not a requirement, but I just advise that you change this line into a division sign so that you may avoid having a fraction on top of another fraction. So if we change the tan into sine over x, then this long division line becomes a division sign, and you multiply cos x multiplied by negative sine x. That is our expression. Then from the rules of simplifying fractions in addition and subtraction, when you are in multiplication and division, when you divide fractions, this one is over 1, so we change the division to multiplication and we swap this into 1 over cos x multiplied by negative of sine x. Then I can simplify my expression. So the value of sine x and this sine x, they can be divided. So I'm going to have 1 over cos and 1 over cos. So the answer for this question is 1 divided by cos squared x. Then the expression has been answered using the co-functions and reduction formulas. Now let's have a look at another example just to emphasize the same thing. I want to simplify this expression. If I say 90 degrees, then it's a co-function. And this one, we need to be very, very careful with it because it turns out to be a negative 1. So we're going to change that, and this will become a negative of sine x. So here we are applying co-functions. Then what do we know about the 180, the 360 degrees? These ones are, they need me to apply reduction formulas. So those are the two items that are there. The moment you get an expression like this, look for those two: reduction formulas, co-functions. Reduction formulas, co-functions, followed by identities. So the numerator of my expression is going to become a negative of sine x. Then the denominator, tan 180 minus x, is going to be negative tan x because it is in the second quadrant where tan is negative. Cos 360 minus x is equal to cos x because in the fourth quadrant cos is positive. Then after that, I can apply my identities. The negative divided by negative will become positive. So this is equal to sine x divided by tan. Each time you see tan, it is sine x over cos x, then multiplied by cos x. Now in this expression, you can see that the cos of x and the cos of x, they can be divided. And sine x divided by sine x, everything is out. The answer to this expression is equal to 1. We have answered an expression using co-functions and reduction formulas. So generally we expect marks here and here and here for changing those expressions, for changing tan, and also for the final answer. On average, we expect this kind of questions to give us 5 to 6 marks in the exam. That's co-functions and reduction formulas.